Okay. Work and potential energy is done. We're now talking about conservation of energy. And first, let's write down this definition. Law of conservation of energy, you can put this on 16. Energy cannot be created or destroyed, it can only change phase. We did classroom demos for this. You're not going to get to see them. So we're just going to do the best we can online. Sorry. Okay, pause the video now if you need to write this. I'm going to bounce back, but you can pause. But let's watch this really quick. Hopefully you're done writing that down. Okay. What we have here is, first we know this. The potential energy as I lift up this ball is increasing. And as I lift up the ball, height is increasing, so potential energy is increasing. But watch what happens when I drop the ball. Look at the kinetic energy. So I want you to take a few notes on this little web page I've got here. It's pretty handy. Question number 1. How is potential energy and kinetic energy related? The answer is when one goes up, the other goes down, so they're indirectly related. But I have a few more questions for you to write that are very, very important. If you cannot answer these questions, you're not going to be able to do conservation of energy this second, all right? And what I mean is you need to learn the answer to these questions to really understand conservation of energy. So let's go back over here, if you will. Question number 1. When the ball falls, potential energy decreases because... You need to be able to answer that. Kinetic energy is increasing because so finish those sentences, write them down and finish them. If you cannot, pause the video, try to figure it out. Let's watch the video again. Maybe that'll help. No. Yes. Okay, don't pay attention to the ball bouncing back up. Just watch it fall. Okay, falling, stop. As it falls, what happens when it falls? Kinetic energy is increasing. Why? As it falls, potential energy is decreasing. Why? Okay, potential energy, because height is decreasing. Kinetic energy, as it falls, velocity is increasing. Potential energy is all about height. Kinetic energy is all about velocity. This is your basic question. You need to be able to answer this, or you cannot pass go and you cannot connect $200. $200? $200. Okay. Energy cannot be created or destroyed. It can only change phase. In other words, back to the video. This is as good as we can do because you're not in class. When I pick this up, the potential energy as it falls is being converted to kinetic energy. It's changing. This energy can't just come from nowhere. First, I do work to lift it. I'm doing work to lift it, giving it potential energy, and then it drops, and the potential energy becomes the source of the kinetic energy. That was a great toss. But it can't come from nowhere. I do work to lift. Potential energy becomes kinetic. And the problem is, in life, and this is good to know, okay, there is no perfect change of energy. Some energy is always lost as it's bouncing. So it's not bouncing up and down forever. However, in our physics problems that we're going to do, we're going to assume that there's no friction or air resistance. But in reality, there's always energy lost. Okay. So here's some questions for you. Question number 1. This is the roller coaster goes like this, and then it comes down. Whee! Okay. I'll put D all the way down here. I'm going to put C right here. Okay. Where is the max potential energy at? A, B, C, or D? Remember, look back at the sentence you just wrote. Where is, what makes potential energy? Height equals max height, B. Where's the max kinetic energy? Well, where is it going the fastest? D, down here at the bottom. So where is potential energy equal to kinetic energy? And it's halfway down. Half of the potential energy is still there, and half of it has become kinetic energy. So at halfway down, as the energy is being transferred as it falls, let's see, kinetic energy and potential energy equal halfway down. Let's try some more. Where is the minimum potential energy? Pause the video so you can think. The answer is at the bottom, where there's the least amount of height. Where's the minimum kinetic energy? Well, if you've been on a roller coaster, where's it going the slowest? At the very top. Let's go on to our proficient idea. Okay, we're not going to look at this. We're not going to look at this. Okay. Energy is being transferred, and here's a fun fact. This is super helpful. Potential energy at the top equals kinetic energy at the bottom. Potential energy at the top equals kinetic energy at the bottom. Here's a nice little ramp. If I lift a ball up to the top right here, 5 meters, 1 kilogram. What's the kinetic energy at the bottom? Going to, as it rolls down faster and faster and faster, what's the kinetic energy down here equal to? This is all you're going to get. Okay. Okay, so let's find kinetic energy. Kinetic energy equals mass times velocity squared over 2. Kinetic energy equals 1 times how are we going to do it? We don't know velocity, but we do know this relationship. The potential energy at the top equals the kinetic energy at the bottom. You do have enough to find potential energy here. So now, solve for that. Equals 5 times 9.8 times 1. I think it's 58.8. 5 times 9.8. Nope, it's not 58.8. It's 60? 50. 49. Okay. 5 times 9.8. Equals 49 joules. That means kinetic energy also equals 49 joules. Let's look at our handout from today to help us go through this. We have, let's see, where is it? Is this the right file? Yes. Conservation of energy. Review. Open. Okay. I'm going to walk you through this. This is a tutorial on this handout. First thing, basic. Label where the max potential kinetic and where their equal is. See if you can do it. And then like draw everything along with me on your notes. Well, this is max PE at the top. Right? This is where it's going the fastest. This might not make as much sense to you. This is a swinging pendulum. So it goes slow, fast, slowing down, stop. Whoa. 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 So if you've been on a swing, you know what this looks like. Okay, picture this as a swing. This is max kinetic energy. And halfway between the two is where they're equal. That's the basic. Let's go to proficient now. Okay. This is not proficient. This is advanced. Solve for this one. Okay, the answer is 58.8 joules. Make sure you can solve for that. Now let's do the advanced. Okay, here's what I want you to do. Draw this. Ignore these two. Fill in these. When you're done, find velocity at the bottom. Okay. Pause the video if you don't want to hear the answers. Here's the answer. Potential energy at the top, you just use the formula, is 196 joules. At the very top, it has 0 velocity, so kinetic energy equals 0. At the very bottom, it has 0 height, so potential energy must equal 0. Where did all this energy go? Energy cannot be created or destroyed. Well, it all became kinetic energy. Here is your advanced question, however. Doing this is your proficient. Your advanced is taking it one step further and finding velocity. Now we can use our kinetic energy formula. Ke equals mv squared over 2. 196 equals 4 v squared over 2 times 2 times 2 equals go over here where there's more space. 392 equals 4v squared. Divide by 4. Divide by 4 equals 98 v squared, and then square root it. 98 square rooted equals velocity equals 9.8. For more practice, go to the web page on the Work and Energy Assessment section, Work and Energy Unit, Assessments. Open up quizzes and practice with the kinetic or conservation of energy quiz.